Hello everyone, welcome back to Coding Charms. In today's video, we are going to be discussing about a most common problem solving pattern, which is sliding windows. Let us see when sliding window pattern is used. When we are dealing with arrays or linked lists and we have to find something in a continuous subarray or sublist, then we use sliding window technique. Sliding window is a portion of a array or a list, okay, and we want to find something in the continuous part, then we use this sliding window pattern. The length of the window can be constant length or variable length. So there are two types of sliding windows. One is constant length sliding window and second one is variable length sliding window. So in the upcoming lectures, I will try to go over the problems covering both these sliding window approaches, and we will solve so many problems using them, and then we can understand the pattern in detail. So let us understand the sliding window pattern by taking an example. So given the problem is we are given with an array and we have to find average of all continuous subarrays of length k. Let us see one example. So here is one example, and we are given with an array and k value is 5, and we have to compute the average of all continuous subarrays. If we see the example or the problem statement, we are given continuous and subarrays. We know when we have something continuous and for subarrays, then we can use sliding window technique. But firstly, let's see what is the brute force or the naive approach of solving the problem. So firstly, we are given with the numbers 1, 3, 2, 6, -1, 4, 1, 8, 5. Okay. So what we can do in brute force way. So firstly, we can go over each subarray and calculate its sum, then divide it by the k value to get the average, right? So firstly, the first array will be this. First subarray will be this. We calculate the sum. 1 plus 3 plus 2 plus 6 minus 1. It will be 11. 11 divided by 5 will be 2.2. Next, we go to next window, next subarray with size k, and then we again compute the sum. 3 plus 2 plus 6 minus 1 plus 4. The sum will be 5 plus 6 will be 11. 11 minus 1, 10, 14. 14 by 5 is 2.8. Similarly, we next calculate for this array, then this array, finally for this subarray. For all the subarrays, we calculate the sum, then we divide it by k and we compute the average. What is the time complexity of this approach? The time complexity of this approach will be O of n into k. For all the values, we are going through the k length subarray starting at that value and we are computing the sum. So for each value, we are going through the k length array and computing the sum. So the time complexity will be O of n. Can we optimize it? If you carefully observe here, this portion of the subarray is common in both first subarray and second subarray, right? This portion is common in both the subarrays. We are recomputing the sum of the common portion in both subarrays. If you see here, we are computing the sum, and here again we are computing the sum. In some way we can reduce recomputation, then we might improve the time complexity. So what are we doing here? In the optimized approach, what we will do is, see, if you observe here, the 1 is getting removed over here and we are additionally adding 4. So let me rewrite the numbers. We have 1, 3, 2, 2, 6, minus 1, 4, 1, 8, and 5. So now what we do is, like similarly like we did in the previous case, we calculate the sum of the first subarray. 2 plus 6 minus 1, 11. 11 by 5 is 2.2. Okay. Now, in the next, while we are moving to the next window, we just slide this window by one step. Okay. So now we are at next window, next window of size k. Here we use the previous sum 11. We decrement we remove the element, or we subtract the previous element, and we add the new element which got added to our window. So we subtract 1 and we add 4. So now it will be, sum will be 14. 14 divided by k will be 2.8, right? Now in the next again, we move the window, we slide the window over one step. Now we have to remove 3 and add 1. So previous sum is 14. We have to remove 3 and add 1. It will become 4. 14 minus 3, 11. 11 plus 1, 12 divided by 5 will be 2.4. Right? Next, similarly, we move this window by one step. We slide it over there, and now we have to, we move the window, and now we should remove 2 and we should add 8. So previous sum is 12. We should remove 2 and add 8. It will be 18. 18 divided by 5 is 3.6. Next, we again slide the window by one step. Now we have to remove 6 and add 5. So what is the previous sum? 18. 18 minus 6 plus 5, it will be 17. 17 divided by 5 is 3.4. So in this way, we can calculate the sum. So here we are removing the recomputation by using the previous sum and removing the value which we have left behind, adding the new value which got added into our window. What will be the time complexity of this approach? The time complexity of this approach will be O of n. So let us code it up. So here I have already coded up the main function. Firstly, we have array and k value. We are passing the array and k value to get averages of k length subarray function, and we are getting the result. And here we are printing the result. So our aim is to implement get averages of k length subarray function. So let's do that. Firstly, we start by computing the length of the array given to us. And then what we have to do, we have to calculate the sum of first k length subarray. So let's name it as current window sum. Initialize it with 0. Now let's compute the current first k length subarray sum. It will be I minus k, I less than k and I plus plus. Now current window sum plus equal to array of I. Now we have the sum of first k length window. Let's initialize the result array. Double result equal to new double. What will be the length of result array? N minus k plus 1. For array length n, we will have n minus k plus 1 length k subarrays. So next, we already calculated the sum of first window. So let us calculate the average for it and add it to result. So current window sum divided by, so average is double, right? So we typecast k value to double so that the overall result will be double. And next, for int I equal to 0, I equal to 1, we move the window to second. From the second, we are using this loop. I less than or equal to n minus k, I plus plus. And what we do, we have previous window sum. This is the previous window sum. To obtain current window sum, what we have to do, we have to decrement the previous value. So previous value will be array of I minus 1. And we have to add the value which is newly added to our window. So we will add array of I plus same minus one value, the value which got newly added to our window. And now we calculate the result. So let me copy this and paste it over here. This will be result of I, and finally we return result. So looks good. Firstly, we compute the sum of first window, and from the second window, what we do to obtain the sum, we remove the value. We move the window, right? So we remove, if we are, this is the window. In the next case, this will be our window. So we remove this value and add 4, the newly added value, to get the current window sum, and we take the average and we return the result. So let us run it. We have to get these numbers as the output. So we got 2.2, 2.8, 2.4, 3.6 and 3.4. This works. What will be the time complexity? As we have discussed, time complexity of this approach will be O of n, and space complexity, if we ignore the result array, the space complexity will be O of 1, since we aren't choosing any external space. We are using only constant variable to compute the sum. This is the result array. So including result array, it will be O of n. So this is all for today. I hope you understood the sliding window pattern, and in further videos we are going to be solving more and more problems over sliding window pattern, so we can fully understand the pattern and we will be able to solve any problem given in the interview. So make sure you subscribe to the channel to get notified whenever I post such useful content. And if you like this video and understood the pattern, make sure you like the video and keep practicing. See you all in my next video. Bye.